In this example, we're facing a situation where we have a cross-section of a beam with an axial stress of sigma x that's acting on the end. Over the top half of the beam, it's a constant sigma naught. Over the lower half of the beam, it's a constant of 2 sigma naught. The depth of the beam into the page, we'll call that dimension t, and of course the height of the beam we can see there in the picture is 2b. What we want to do is replace that two-part uniform distribution of stress in part A by a single force and a couple, and part B, if we wanted to replace it just by a force by itself, where would that equivalent force need to be? So let's first replace the two pieces of the distributed load by discrete loads. So here is the cross-section of the beam again. The top half will represent that resultant force by F naught, where F naught is the stress of sigma naught times the cross-sectional area of the top, that's just B times T. On the bottom, it's 2 F naught, because the normal stress is twice as much. So this dimension here is B over 2, same for here. C is the center of the beam. So on the cross-section, what we have, if I make this X and Y, summing forces in X on the face gives me F naught plus 2 F naught. So that gives us a total resultant force of 3 F naught, which is equal to 3 sigma naught BT on that face. If I were to calculate the moment about C due to those two loads, the force on the bottom, 2 F naught, it has a moment arm of B over 2, it's a plus sign. The force on the top, F naught, has a moment arm also of B over 2, but it's in a negative direction. So that's going to be simply F naught B over 2. So F naught B over 2 becomes sigma naught B squared T divided by 2. So this is what is happening on the face due to that uniform, those two pieces of uniform axial stress. In the first case, what we want to do is replace that distribution of load by an equivalent force here of FEQ and an equivalent couple of MEQ. So it's easy to see from here, I think, that is the equivalent force then must be none other than that total resultant force of 3 sigma naught BT, and the equivalent couple, being as it's placed at C, the equivalent couple would be MC, so that's sigma naught B squared T divided by 2. So that's what the force couple is at the center point. If we wanted to replace this not by force on a couple, but by a single force, where would that be? So this is point C again. We're going to have this same equivalent force, FEQ. That doesn't change by where you place it. But there's going to be at some distance D, which we don't know. So for this load, if I do summation of moments about C, I get the equivalent resultant force FEQ times D, and that must be the same thing as our moment about C in the original picture, which is sigma naught B squared T over 2. So this says then that the distance D then would be to take the sigma naught B squared T divided by 2 and divide it by the equivalent one, which was 3 sigma naught BT So the T's will cancel out. There will be a B which will cancel top and bottom. The sigma dot does. So this becomes the distance of B over 6. So to replace that distribution by a force and a couple, we've got that. That's for part A. If we want to replace it just by single force, that would be where we could put a force but no couple. It would have to be placed at a distance of B over 6 below the center line of that beam.